Okay, so now we will we'll add more features to it before we can concentrate on the shadow acne. So it's not a bad idea to rotate the light source so that it will be little bit animation, and we can see that. So we will uncomment it. So and we'll introduce the keyboard function. Okay, so light position we are going to modify. So global light, and then if R is search, yes, Python has everything. Whatever you need, it's there. Best regular expression, light position. Okay, so we will make up, down, so 2. If key equal to up, else minus 2. L if up or it is right. Then in this case we will X will shift, and then we will say near and far, and then we'll modify to near is first. Okay, so glut post redisplay, and then so based upon the keyboard, we will modify it, and the light position. So light position is at the beginning, so very nice. And once light position modifies, then our light source would change, and we can see the light moving. We can try it. Okay, so light source is available, and idea is I can move the light. It's moving. This is what I wanted. Now shadow is on this plane. This is the shadow of this. So see, the shadow acne is more prominent. So if I bring it down, can we see as it is becoming, if the shadow is growing, it is going in X direction, acne is growing. See how big acne is, and it is becoming smaller the way the light source is. Anyway, I think it's nice to have this moving a little better. So we'll have one more guy, so we will implement it. So we can say a window width, window height equal to 800 by 600. So at the beginning we'll set this, and then we will do some tweaking. Okay, so here in reshape function I'll introduce mode. Okay, something like none at the beginning, and okay, so once all the work is done, I can say window width, window height. equal to if not mode, okay, else window. Miss amazing, miss no one can believe like someone can write code like this. Window width, window height equal to WH if not mode, else window. Amazing. Okay, so this is done. Now if reshape is called by the kind of Opengl code, then mode is none. So if that case, it will reassign the window width and height. Okay, so we'll say it is global. Window width, window height. So Mr. Width and height are global. So we can modify it. And now here when we call it reshape, then we will add parameters. So I can say here shadow means anything. Anyway, we are not checking it. Reshape mode equal to shadow, and again reshape. We can say something like window. So these are the kind of I can grep on the reshape. Okay, so if reshape is called by ourselves, then we are passing extra parameter. Okay, so we'll try now. So okay, so 800 will search. So here in the final pass we are calling 800 by 600. Now it is window width, window height. So what we are trying to do is that we'll remember window width and window height if it is kind of called by the system, and then we can kind of call it again. So if it is from system not mode, then we modify it. We'll try it. Okay, now I am going to maximize it far better. This is what the imagination is. Okay, so now it is better. Now I can rotate the light. So white cube is light. So light is going on the next surface. So this is shadow of this wire sphere, and if I move the light up, then shadow will come on the table. Down it will go to. Okay, so full-fledged it is making the shadow. Okay, I can bring it near, then shadow would move behind. So this much. Okay, so more we'll see. So why it went away. Okay, so it is in documentation that it is a matter of research, but I little bit disagree. Means if you kind of understand the nuance, it's kind of miniature Opengl. So every nuance of the Opengl, then you can crack it. Means it's not that difficult. Okay, so amazing. So it is making the shadow, one thing. Second thing is, can we see the shadow icon? This unpleasant shadow is coming up, and this unpleasant shadow is everywhere. I mean, I am going to replace it with so where I'll say solid. On the sphere also it will make. I don't know, it is visible here. Okay, looks like it is not making. So thank you, it's making. Okay, so I mean it should be more visible if I have no idea how I can hit. I have not put that provision. So GLU perspective, I can make it little kind of 30, and then light position, this will make it smaller so that it should be visible. I hope so. It's visible. Shadow acne is getting formed on spheres. Can someone see the change in the sphere? So, see, it is covered now. See, it is changing. Okay. So this is the problem. Means it is prominent. Shadow acne is prominent now. So the idea is how we can reproduce this. If light is kind of horizontal to the means if y axis is less and the shadow is kind of larger, then shadow acne would be more. If it is perpendicular, then it will be less, smaller. Will be smaller if it is exact perpendicular. But if it makes angle, if it makes more angle, then it is more prominent shadow acne. Okay, so this is the kind of unacceptable. Okay, so you are achieving something, you are earning kind of $10 when you are wasting $1,000. So it is something like you are achieving something, but you are losing much. Means who will accept this? No one can accept this. So in the name of shadow, we are getting this much in reward. Okay, so that we'll tackle later. Now the question arising is that whatever the light is seeing, okay, so when light falls on the sphere, means there is no lighting anyway, it's a complete mathematics and it is just matrix multiplication, but still when light is falling on the model, then how it looks from the light perspective. If I take a photograph, okay, so if I bring a cameraman, if I bring a photographer, and then it's a kind of it's impossible to find anywhere, means how to take photograph. So what light source is seeing, so how to take photograph. Okay, whatever we are seeing now, so nice, means I mean whatever we are seeing now, that is from the camera. So camera, we have done glut load and we have shifted the camera from the origin. Okay, so in the code, if we see, so if in the code, if we see, okay, so my 6060, we have shifted the camera also. It's not at origin. Okay, if this is the scenario, so whatever we are seeing, that is from camera perspective. Okay, now when it is making shadow, how light is seeing means I gave a hypothetical kind of analogy, light is seeing like this. So hypothetical kind of we gave, like when light is coming to the center, then it is giving something like this. Okay, but I don't know. Whatever we are seeing, that is from the camera perspective. What is from the light perspective, that we don't know how it is taking the photograph. So as I said, all are our local code. So we'll try writing it. So how it would happen. Okay, now we understand that whatever the frame buffer is drawing, that is getting captured in kind of texture object. So there are three things: frame buffer, texture object, and the memory. So at the memory, image is stored, so that we upload through GL text image 2D, but anyway there is no image, but texture image is ready. And second, so one is memory, one is texture image, means texture object, and one is frame buffer. So in frame buffer, when we talk about the image, then mainly it is color buffer. So that mainly we we discuss. So that is the color buffer. But anyway, I think it's understood that color buffer is muted. It is set to null. So that whatever frame buffer is drawing, so we have attached the frame buffer, GL depth attachment, to the texture 2D. So whatever the FBO, so we have bound the FBO, and then we have done all the great thing in the texture object. So this texture object is bound to this FBO, and then we are saying explicitly that FBO should be drawn on the texture object. Now, if we have texture object, so this proves that things are getting drawn on the texture object. So if that is the case, then can we texture object can we put on the magnetic tape so that we can see it? So can we place on reel the texture object so that we can see it? So now in the first go, we are creating the shader. So here, when we unbound the frame buffer has already copied the texture object. So frame buffer did all the camera stuff. It did all the recording, and when we unbind it, means GL frame buffer 0, so texture object should be ready by now. And in this case, we are happy that now I'll say bind texture. Okay, so GL texture 2D and shadow texture. I'm not going to make it global because it is read only. So I think it's okay. Okay, now I will say okay, texture image or temp texture image, so that it should not collide with anyone. And then we'll say GL get text image. I don't know there is a help or not. Python 3 from opengl.gl import star, okay, and help in the GL get text image. Okay, so return the pixel data array in the format defined by the format type and output type. So whatever is in the texture buffer, so that should be returned now. So that is the idea. And then we have to place all the grammar what we want. So GL get text image. Okay. So GL get text image and GL texture 2D 0, GL depth component GL float. Okay, so GL depth component is a kind of type we are using. Otherwise we could have used GL RGB, GL RGBA like that, but this is for the depth that we are using. GL float is float, GL float we have used. So this is GL float. So if it is very far, it is 1. Otherwise, so everything is kind of normalized between 0 and 1. So that is GL float. Nice. So GL float, GL depth component 0, GL texture 2D. Okay, now image from bytes. So we are going to create image, and this image is a kind of bit image. I mean, it's a kind of monochrome image based upon the gray level, not in RGB value. Shadow width, shadow height will convert bytes, and the way Python is, you can write a big thing in so small. So 100 into 255, I'll tell you what we are trying to do. For X in temp texture dot reshape, 1 shadow width, shadow height, transpose image, flip top. I mean, there are languages to do shorthand when you write many things kind of. So I'll say depth shadow texture dot png. Can someone believe this is Python code? Okay, so what we are trying to do is, from bytes we are creating the image. Image format is L. Shadow width and shadow height is the image width and height, and then data what we are receiving. So for X in temp texture, so temp texture is a array of width and height. So we reshape it 1 into shadow width and shadow height. So it will become a kind of single row data, and then we fetch the data completely, and then whatever data we are receiving, so that data then we do power of X into 100. So all the data is in point maximum 1, so it's completely alright. So if data is near, means 0.5, then it will become even smaller. So data is bigger, it will be bigger. Data is smaller. So this is what we are, so that it should be visible. Whatever we are achieving, then we are multiplying by 255 so that it will come to grayscale. and then int. Okay, so there is no boundary here, so I believe it's alright. From bytes, and then we transpose it top to bottom because image is shaped. So origin in the Opengl is bottom, where image origin is on top as per the image fundamentals. Save to depth shadow. Amazing. Means it is mind blowing. No one can do it. Is it too much? I mean, it's okay, means it's done. That's it. So what we did is, once the frame buffer is unbound, then we bind the texture and then we get the texture image. Okay, and texture image is finally then this much we do, and to get that. So we'll try again. There is no harm in trying. So there is nothing, only file is there. Okay, so it looks like it is showing error. Temp texture is not defined. Temp texture image. Okay, so temp texture image is what we meant. Image is not defined. Okay, so name image is not defined. Okay, I mean, we expect something now. So I'm closing it. Image is ready. Mr. Nemo. Image is ready. Can you believe this? So this is wireframe on top. I mean, there is no harm in enlarging it. So nice. So this is the actual black and white photograph that used to happen, I think 30-40 years back. And so this is what it has taken. So the top is white, what we see. White means this is the end, and then down it is the table that we have drawn. Then so it's so nicely it is come. Okay, now we'll keep moving it and then we'll see. Okay, so Mr. Nemo is not happy. Okay, so idea is that we will move it. It is moving. Okay, so we will add one sphere so that it will be more prominent. GL push matrix. GL color will make it red, and GL glut solid sphere, and radius 1 will keep it small, and GL pop matrix. Okay, now we'll try to get it. Okay, we can see clearly red spot. So this light is pointing on the red spot, and in between it is saying this sphere, wire sphere, and it is creating the shadow. Now we can rotate the light. Okay, so From this perspective, light will come on the red spot. So this should come, I believe, on the left side. Okay, so this is how it is. So right side it is showing complete white and it is showing top around center. So when it is seeing the right side, this is sphere, this is light source, this is center. So on the right side it is blank. So value is coming as white, top right. Okay, and bottom anyway table is there and table is near, so it is dark, and up is the yellow one, so it is kind of far, so it is little whitish, and then this is like this. So if I make it come near, okay, so it is seeing the red spot, and then I think this is exactly on top of red spot. So that's why it is coming in the center always. So we'll try to move on the left side, so that we'll see. So we'll translate it to kind of minus some 10. Okay, now light will move. Now sphere is seeing the red spot, and this is coming on the left side because it is minus 20 now. Okay, it is not only y directional up, it is behind the scene also. So it should come on left. It is exactly coming in the left. Can we see? Okay, so this is how we can take a photograph. Okay, so what the light source is seeing. Now the light source and this red spot, they are in line. So this sphere should come in the center. It is exactly in the center. It is auto refreshing. It is exactly in the center. This is how it is. Okay, so this is how. Now only item that is left before we start the shadow acne, this raster data. So whatever the image we are drawing, so that image can be stored in a file. Okay, how we can see, because this is a PNG image. So for that we'll write the code. So we'll say like file equal to open, okay, shadow raster dot text, and then for row in temp texture image, file dot write join round x 4 or 3 for x in row, file, okay, so file open shadow raster dot text width, and then we are trying to do some magic and we'll see now. So we'll close this. Okay, so now there is nothing here. So we'll try to make it. Okay. Okay, so that is gone. Okay, this is the last thing we are doing. Temp shadow. Okay, so row in temp texture image file dot write for x in row file dot write star dot join Okay, so we'll make it a string. Okay, so we'll try. It will be slow now because it is writing to the file. Okay, so it is slow. Every processing is slow. It is slow because it is writing to the file. Okay, so we'll have now file and shadow raster text. So this is the raster image it is generating the way what we are discussing. At the bottom it is 1. So the bottom frame is white. So that we will see it is really white. Okay, so top is white because image is upside down the way Opengl and image fundamental works. Otherwise this is what we expected. Okay, so we generated image and raster data all. Since every moment it is creating the image and then file, so it will be slow.